even in computer science, mathematics. He's a well-known figure in the country as well as all over the world. I know him since last 26 years. When I was doing my PhD or almost finalizing my PhD thesis in Bennett University, Australia, he was apparently in Melbourne during that time, and I invited him to Bennett University. And he gave a talk 26 years ago, 27 years ago. And since then, we have this nice academic father-son relationship. He's more like an academic mentor. A lot of publications, a lot of contributions. So one thing which I always remember is focus on quality aspects. At the same time, volume. If you look at his publications, so I'm telling things which you cannot find on the internet. But those things you can easily find if you read his profile. So he's still very active in doing research. You look at his publications page, you see publications in 2020. And most of his publications are in top-tier journals. IEEE Transactions, many others categorized as too difficult to publish. You should imagine now it is very easy. Imagine 50 years ago when you didn't add much things, much resources, making a photocopy, writing papers, looking at literature, a lot of things were not possible 50 years ago. So he developed from that stage to modern stage. So he's one of those professors who has seen the way technology has transformed our country. So I would strongly recommend, especially youngsters, not just listen to the talk, but it's also an opportunity to understand a person in depth. Sometimes, if you look at the personality, you can also learn a lot of things. How someone has grown over years. So even if you're not working in the AI field or pattern recognition field, or even machine learning field, you can learn a lot of things. So even if you look at his web page, as I mentioned earlier, it's still updated. And at his age, and I'm sure some of the faculty members might not even have a personal web page. So even at his age, he's maintaining his own personal web page. And if you look at his profile, you see it's updated. So that shows his passion towards research and various contributions. He has 2 PhDs, 1 PhD from University of Calcutta, 1978, second PhD from Imperial College London, 1982, several postdoctorates, University College Berkeley, University of California, Berkeley, from NASA, Imperial College London, and then he started his career in ISI course. He was founding director, and now he has formally retired, but still he is the president of ISI. And besides that, he is very passionate about it. So yesterday he came to Delhi, first he went to DST office, he had a meeting. So you can imagine the passion he has towards contributing towards research and contributing to the community. So a lot of things we can learn from such personalities. So on behalf of Bennett University, the entire fraternity, this is my great pleasure to welcome Professor Sankar K for joining us for this seminar series. And we have Professor Akansha Singh. She has been the seminar coordinator, bringing all these speakers together. also want to announce something very new which we are launching today, Bennett Engineering and Sciences Transactions. This is an initiative by the university to promote undergraduate student research. So now onwards, we encourage our undergraduate students to publish their findings. Could be anything. Could be some reports, could be some semi-mature papers. And we provide a platform for them to showcase what they have done. So taking this opportunity, since we have the global star researcher, I would like to request Professor Sankar to formally launch this journal. So I think the journal webpage will be hosted on the website, and if you look at the website, you will find all the details. There is a call for paper, the procedures we followed, templates, and again, I would like to thank Professor Singh for volunteering to be the editor in charge for this journal. So all of us, please join to thank her. She's not only thank you, but also we need your contributions. So all faculty should motivate, encourage your students to contribute papers. So without any further delay, I would like to go into today's talk by Professor Sankar. His talk will be on granular mining in video analytics, shallow to deep learning. You could see the spectrum of knowledge is going to cover. You can see it covers a lot of media, images to video plus machine learning. So it's a very nice intersection. So without further delay, I would like to pass on the stage to Professor.
Thank you. Good afternoon. Before I talk, there are one or two words regarding this journal. As your Vice Chancellor Ram mentioned, that you need to contribute. But more importantly, as I've seen, initiating something is difficult, but maintaining for a long time, that is even more difficult. And on the top of that, maintaining the quality, that's important. Country needs quality. So I will just one or two words for our young minds that are there. Keep that in mind. This is a very good initiative that from school, from undergraduate level, you have a habit of publishing. That's a very good habit. Because at the end of the day, as a researcher, that's the only thing you will be judged by. So it's not the number. You maintain quality for entire career. And that's how you learn from it. So it's my all best wishes for this journal. I hope after a few years, many other universities will be just following this technique. Okay, thank you very much. Now the talk, as I said, I think it is mostly undergraduate students. So I don't know whether it is suitable, but I will try to explain very lucidly. One, as the title you see, very interdisciplinary research, but I will not use any mathematics or any result much, only the concept and few diagrams and some results. So, and if you have any question, even if it is a very layman question, don't hesitate to ask me. Yeah? So granular mining, so granulation computing, data mining, video analytics. And when you set the video, image processing is must. Because videos means number of frames. So unless if you do not know image processing, you don't have basic idea of video. And I started working in image processing in '79. So that time there was no book at Imperial College. So that's what I did it. Now, the way I prepared my talk is follows. You have granular computing, I'll be explaining in examples the components. Then rough set, that is one of the hot topics we have been working for more than a decade. Yeah, more than a decade. And why rough set is required for granular computing? That's the concept. And don't get upset with the names rough set. I will explain with some examples and diagrams so that you can have the clear idea. Then you can develop with your mathematics, with your knowledge. Then general life set, that's my very popular topic. We have been working for many decades on giving some good entropy definition. So entropy is a very catchy word. If you want the entropy very cleverly, then your publication possibility increases. So you have to be very carefully entropy. And entropy, those who are from physics, they know entropy. Those who are from communication, they know entropy. So those who are from Phase theory, they have entropy. Now rough set also have entropy. We have defined. And then I will explain only one video analytics as an example. There are many big data, video analytics, and significance of lower and upper approximation, tracking in ambiguous situations, that means what are the challenging areas. If there is no challenge, there is no success. So you have to handle always the challenging issues. There's some new concept, rough filter, granular program, and last, granular deep learning. That's our recent activities for the past 7 years. That is deep learning and granulated deep learning. The last part, more important for the beginners, challenging issues and certain concerns. I will mention. How much time so that I can skip also some slides?
We have about 40 minutes.
40 minutes. So I will skip a little bit slide. Okay. So what is basically granulation? See, I'm looking at the audience. I can see some ladies, some boys there, some little older people are there, some younger people are there. So without looking at the particular audience, I can consider granular. In audience, I don't know your interest. Some old people, some young people, some lady granule, some lady mixed granule. It's called granule. So when I look at a scene, what is called here? Sky, vegetation, open space, habitation, river, water, that's all. So basically it's replacing a fine-grained universe. Our universe is fine-grained, but we make it coarse-grained, more in line with human perception. That's what we see. Therefore, it's a process like self-organization, self-reproduction, morphogenesis, terminal evolution, and so on, that are abstracted from natural phenomena. And in the process, clusters or segments, that is the cluster of women, cluster of old people, cluster of young, is called granule. So, it's basically what should I click? The pointer. No. Yeah, otherwise. What should I click? No, it's okay. See, technology is not competitive. This manual is good. I can see what is the one. Therefore, it's a process of formation of granules and representation of granules. Two things. Formation of granules, obviously, because in the scene, How do I format the granule? That means what kind of information I am preserving. And it is a representation. These are the two issues for granulation process. And in the process, I produce granule. Example. In real life example, so mathematically, what can we say? It's a concept of clump of indiscernible entities. That means the entities object which cannot discriminate it. Just like with anyone, young boys, I don't want to discriminate it. If I want to discriminate, I can make finer granules. But in a real life problem, I may not need always. That means I am losing information, but that means I am compromising some information depending on my need. Therefore, this clump of indiscernible granules means done in terms of say, similarity, proximity, functionality. For example, in the gene expression, you go by similarity in terms of functionality. In a vector space, you go by similarity in terms of distance measure, closeness. In case of image, color similarity, intensity similarity. So in terms of certain parameter, when you compute the similarity, and with respect to that similarity, when you cannot discriminate, it constitutes clump. So very simple concept. If you add another dimension, then granular size will be reduced. That is, you are putting fineness. So fineness to coarseness, yes, we are going. Example. So in the age granule means very young. Because I am not bothering about how old you are, just looking at the direction. When you drive a car, slightly left, slightly right. In a school, each class of a school can be considered as a granule because they are determined either by age group or marks obtained in the previous class or sex, some kind of attributes there. In an image, if you look at this, here we have consecutive 6 granules. And as per Weber's law, naked eye cannot discriminate. So 1 to 6, 2 to 7, 3 to 8, I cannot discriminate. So I can consider 1 to 6 as a granule because I cannot discriminate. So now look at this here. Here the granules do not have precise boundary. So granules are fuzzy. Here fuzzy. Here crisp. Here crisp. So granules could be crisp. Granules could be fuzzy in real life. Okay. Now, given a granulated domain, for example, you consider the image or the school. Every section is a granule because section has a number of students different, so granules could be of different sizes. Now, given this granulated domain, I define a. Before that I consider the granular computing. So granular computing is a twofold task. Formation of granule, the abstraction of information from the data or in the scene, from the concept, whatever, and using them for further operation. Therefore, since you are playing with information compression, there is a compression of data. So you are not playing with individual point. You are playing with the information abstracted from the individual points. So collective information you are using, and it's a compression. So therefore, based on the realization, we thought that we can use it for mining large data set, where we do not need precision. Understand? In most of the mining problems, real life problems, we do not need precision. That how many population, we do not want a 10 million point of this. We approximate. How many students are in a school? About 6,000. So you do not need precision in most of the problem. If you need precision, then you start from there and you pay little money to go to that. Instead of starting from the beginning scratch, then you are paying lots of money. Okay? So this is the granular property. Now given a granulated domain, for the image or section, I define a set. This set, some concept, some region, think of it. For example, in a school, some contaminated disease has been spread. That is the set. So now I approximate that set in terms of granules. That is, which are the granules that will definitely belong to this set. Now this is set means I approximate the set from inner side, from outer side, from lower side or upper side. And that is what is, I will explain now with the diagram. Since it's a granule and I'm defining set, so I can approximate the set in terms of granule from lower side, upper side, from inner side or outer side. And this is what is called rough set. The set is crisp, but you are defining roughly in terms of lower approximation, upper approximation, inner approximation, outer approximation. Then example, this is a school. Every section has different number of students, and this is x-axis, y-axis. This is one granule where all the students cannot be discriminated because of their age or sex or not. Now this is my set. Suppose some contaminated disease has been spread for the school. Now the principal has to declare that infected classes should be declared holiday. Now how do you define infected classes? Because there are student sections where all students are infected. That means this granule, yellow granules. Look at this. Which are all definitely belonging to this set. So these are the student sections where all students are granule as marked by yellow. They have to be declared holiday. So this is called lower approximation. That means they definitely belong to this concept. Those granules definitely belong to this concept. There is approximation from inside. On the other hand, there are granules by orange, which includes this. There you can see that some of the granules where all the students are not infected, but at least one student was infected. So this is called upper approximation. So this set approximated in terms of granule from inner side and outer side. Inner side means definitely belonging, outside means definitely as well as possibly belonging. It's called upper approximation. Now we see, therefore I can define lower approximation, upper approximation. Lower means definitely and upper means possibly and lower. And upper minus lower means possibly. And that creates problem in life, uncertainty. So uncertainty is arising because of the granularity. Now if I add one more dimension, the granular size will be reduced, so uncertainty will be reduced. So therefore I can define some roughness of the set in terms of 1 minus cardinality of lower divided by cardinality of upper. That means definitely granules number, definitely and positive granules that number. So if you have lower cardinality, upper cardinality equal, that is 1 minus 1 is 0. That means when it will be lower equal to upper? When there is no granularity. So if there is no granularity, there is no roughness. Understand? That if you are taking image, when you make it discretized x-axis 0 to 31, 0 to 31, and intensity level say 0 to 31, then you are introducing granularity. Where you are losing information, you are approximating. If there is no discretization, there is no information loss, there is no roughness. Clear? So in the image, fuzziness comes because of the sinusoidal variation of the image. Where is the boundary? I cannot say because it is a fuzzy. And granularity comes, rough set comes when I discretize this x-axis into 0 to 31, say y-axis 0 to 31, and intensity level 0 to 8, 7 or 31. So I am introducing discretization. Discretization means I am introducing granularity. This is clear? So that's one basic concept. So rough set is nothing but a crisp set, but with rough description. So fuzzy set on the other hand, there are many examples of large number, beautiful lady, old man, but here set is crisp, but with rough description. And this vagueness of this set X in terms of lower order approximation, that basically signifies the incompleteness of knowledge about the universe based on this definition of X, based on the definition of the set, based on the definition of the granule. Granules are determined by the relation. So just keep that in mind, the vague definition of X, why vague? Because you are granular, you are approximating. In terms of lower approximation, it is incomplete knowledge happening. So when you have incompleteness of knowledge, so you can minimize the incompleteness and make a decision. How can you make uncertainty minimization? Because uncertainty coming from roughness. So roughness means here is incompleteness of knowledge. So you want to reduce the incompleteness, also you minimize it. Now, rough set that I picked up when I was working at NASA Johnson Space Center. I don't know how many of you know that NASA not only does research in space computation, but also they do fund for research to colleges, universities, and your small and medium scale industries also. So that time, I was in there in 92 and 94. There was a recession in Europe. So East Europeans, they are very good in mathematics. They used to come for internship. Just like you go for internship 2 to 3 months, so they used to come. So courtesy, they have to give talk, otherwise they will not get fellowship. So I had an opportunity to listen to this talk. That time I had a work idea of patternization and US procedure. I know what is uncertainty there. And expert system came as a buzzword. So I was listening to them. Then I saw there is a buzzword for expert system defined using rough set theory. So and because of the lower and upper, that can handle the concept of definitely and possibly. And where every decision making, there is concept of definitely and possibly. For definitely no ambiguity, or possibly uncertainty is coming. So I picked up the subject that uncertainty handling can be done. And that time granular computing word was not in my mind, but I can see that granular I can use. So using lower and upper approximation, using inversion. They are the two important characteristics. So after returning to USA, I hired some postdoc who is now a professor in IIT Kanpur, Mohua Banerjee. She submitted a thesis in Calcutta University in rough set theory. So I hired her by taking a CSI fellow. See, how do you learn a subject? You have some knowledge about one domain. How do you learn? No one will teach you. So you take a project, and for this result is always with you. So I took two array, one for my project and one for learning after it. So I hired her. So that's how we started picking up. But her background is this. So we started working. Otherwise, we will just come to work with you. Okay? Very simple concept. Okay? So now I see in machine learning concept, theory, what do you mean by rough set here? So any cluster, machine learning is basically cluster. Classification, categorization, learning. So you have a granulated domain, this is my cluster. Any cluster, ambiguity for belonging of a point to the cluster is minimum close to, if you are close to the centroid. So around centroid, here I have no ambiguity for the belonging. So I can call it a lower approximation. And ambiguity comes from this shaded region. So this plus 2 can be considered as a upper approximation. Right? Possibly. So I can define roughness equal to cardinality of lower and upper. Now in real life problem, there was a definition according to Professor Fowler. He is a great applied mathematician from Poland. But in real life problem, we have seen that both granules and set could be fuzzy. Example, in an image, when you say that, where is the boundary? I cannot say because it is a gray. So set could be fuzzy. Similar granule, because you are in image processing, you must be moving 3x3 window. So 3x3 window could be discrete, 3x3 could be overlapping also. So granules could be also fuzzy. So if one of them is fuzzy, the lower and upper approximation will be also a fuzzy set. Because it's a membership. And fuzzy sets are nothing but membership functions. Therefore, instead of computing the number of granules, you will compute the membership values of belonging of these granules for belonging to the set. So then you compute fuzzy cardinality. And that gives a rise of lower and upper approximation fuzzy, and accordingly we can generalize rough set, which takes care of uncertainty arising because of the granularity, uncertainty arising because of the fuzziness. That is overlapping, but not uncertainty arising from the probability of occurrence of an event. If you can add it to, it will be even much more stronger paradigm, uncertainty modeling. So here is an example I give, is a generalized rough set. This is an entropy definition we have given using logarithmic gain function, exponential gain function. What is logarithmic gain function? If your probability of occurrence of an element is pi, then amount of ignorance is 1 divided pi. Based on that, logarithmic gain function channel. But we say it could be 1 minus pi also. So if I take 1 by pi, we get this, 1 minus pi, we get this. If that is object X and its complement set B. Now if I take a cross section, that is roughness of object A and its complement set equal, then I get this. And this is what, if you look at this entropy quantifies the incompleteness knowledge about the universe again, given the definition of X, that is a measure is gain of incompleteness. Therefore, now consider the image. It has so many applications, let's consider as an object. Because object and background, two-class problem. Tracking means, segmentation means object and background, okay? So I can reduce the entropy, minimize, I can compute it. So if I minimize, I extract the object. The minimized object means you are separating the distance between two object and classes. That is better segmentation. Therefore, first one is minimize entropy, that is minimize uncertainty, that is minimize incompleteness of knowledge, that is maximize object background separation. And that means you apply for object extraction, and within frame by frame you extract object and you track simple way of tracking object. That's what we published 10 years back. But today you cannot publish. So now you come principal two, classification or estimation. But both are unsupervised, I'm asking. Challenge. It's unsupervised. I have no idea one object is coming. And what is video, as I mentioned, sequence of frames. Now what additional, if you have worked in image processing, what value is available to only intensity. Now you have RGB, so RGB. But if you take videos, you have extra one is temporal information. That's the additional information. So if you take difference between two video frames, what you will get? Static portion will get 0, nullified. Only those moving portions which are both present in one, you will cut it. That's our intuition. So now what we will show? We will show that granules you extract arbitrary shape. That's what you see. That the number of size of the very young, so different shapes. So we will extract. How we will extract? You start from a pixel. You compute the color similarity. Put some threshold. That's how you grow. It's called region growing. Your shape will be arbitrary. It's a very common problem in our clustering also. So we have borrowed that concept, region growing. And we take RGB and we take ambiguous. Ambiguous means you are taking one object, suddenly another object comes. Objects are occluded completely. Objects are moving in different directions, in different speed. So these are all difficult situations. And I will explain the concept of rough filter, the granulated deep learning. So first one is rule-based classification. Here I extract the granules of arbitrary shape as I mentioned. I use neighborhood granules, that means I compute neighborhood similarity in RGB and depth information. I extract 3-dimensional spatial granule, 2-dimensional spatial color granule, and 1-dimensional color granule. So granules obtained since unsupervised. In our literature, if you see, what we do basically, we extract a background model. Then we subtract the background from object, image plane, so I extract the object model. But here I say no. We extract the object model. Why you extract model? That I extract the lower approximation. Lower means definitely belonging. So I extract lower approximation and I consider it as an object model. And from that model, I extract granule. I forget about data. So my everything is in granular level. Then I form a granular rule base. I update. So what is lower approximation? The lady is doing exercise. T minus 2, I take the difference. So this is the moving object. T minus 2, this is the moving object. T minus 3, moving object. Just you see the thing. Now I take union and intersection. If I take union, intersection. So this is the portion which is definitely belonging in all the frames in the Moody. If I take T minus 4, you have to take odd number so that you can compute median also. So you will get value, but it will be expensive. So let's consider 3. So this is the portion I call it lower approximation because they, whatever in the 3 frames, they will always belong in the moving region. So I call it lower approximation. From that, we extract the granules as like our pattern recognition problem. And from granule, we form a granular rule base. Now take an unknown and I compute one and make sure that our ambiguous rules, which are representing the ambiguous difficult situation, they do not get fired. Now, this is our median plane. These are my granules. Spatio-color granules, then spatio-temporal granules. Look at this, granules are of different shapes. So this is my granular, this is called spatio-color, temporal domain, spatio-temporal. So from this I extract the boundary. And this is my tau domain, I go back to depth domain, I go back to RGB domain. So I get 3 sets of features corresponding to each granule. Based on that, we map is 10 based on our experience. This is ideal case, background, ideal object. 8 and 9, they are ambiguous granules. Look at the, this is a set form, not belonging, partial belonging, complete belonging, belonging. So you see the 8 and 9, all features same, but they belong to background object. So our objective will be so that our unambiguous granules fires least time. Accordingly, if we fire this upgrade unit, then look, the lady is doing exercise with right hand, tracking. See, in the previous slide, she was doing exercise right hand, but suddenly left hand is tracked, or tracker is unable to work because updation was not there. We made flow graph updation, and it is intelligent. That is only in the rule base we change that feature which is responsive, not the all features. But when I say the successful, see, tracker is tracking to track. That is, you are tracking one object. Suddenly you move down. So you are tracking one car, suddenly another car jumps, you are able to track it. The person moving in different directions is different speed. This is a reflection on the wind. Since you are using depth feature, so the shadow is not being tracked. Because with the depth information, shadow is not coming. Because depth information doesn't change with the work. Only if you moving object, only the depth information changes. Now come to handling overlapping occlusion. It's called estimation based method. Okay? That means previously was classification based method and there is unsupervised. This is also unsupervised. Here we will go prediction. So here again I am using the same, that temporal domain and rough and the spatial color similar. So what I do before I look at the one, I take ft minus 1, t minus 2, t minus 3. I take its union, I get 1 image. T minus 1, t minus 2, t minus 2, t minus 2, t3. So I get 3 images. So 1 and 3, I take convolution. Those are from electrical engineering, they know the definition of convolution. So I take 1 to 3 point convolution if I have 3 previous matrices. I generate 3 matrices. one corresponding to lower, one corresponding to upper. How I will explain? So lower means those are definitely belonging to those three frames, and upper means possibly belonging to three frames. So when I have this definition of this color of three frames, definitely possibly, similarly I can compute for them displacement, acceleration, speed. I can estimate their values in the next incoming frame. And everything I am getting in terms of lower and upper. Lower and upper. And from I compute the lower roughness. If roughness is minimum, below a threshold, I track it. If it is not, I say it is occluded. So then what is it? I compute intrinsic entropy, which quantifies the amount of occlusion. And I put that lower minus upper pixels either in object or background and see where roughness is getting reduced. Accordingly, I it's very simple. So this is my T minus 1, T minus 2, current to all previous P frames. I take one P. This is between all consecutive frames. So I get three P frames. So input of derivation is a basically convolution. P to 1 point convolution. I get two P point matrices. One is lower and upper. And here convolution upper is minimum intersection operation, linear operation. If it is intersection operation, we generate lower approximation. And if it is upper union operation, out of those union operation, granules generated after union operation, I select only those granules which have non-empty intersection of the lower approximation, as per the definition. So look at this. 3 to 1 point convolution, lower approximation, upper approximation. Definitely belonging, definitely and possibility. So from that I can compute in the next category displacement, acceleration, speed, and find a possible approximated solid. Location in terms of lower and upper. And look at this. And I compute the performance measure in terms of signal to noise ratio borrowed from electrical engineering. Lower cardinality of lower, cardinality of upper minus lower. Lower means I want to get it more. That the lower approximation should be more number. And upper minus is the cardinality or power noise. And lower signal to noise ratio means port function. So if it is a lower, we need to make it higher. That is, this numerator could be increased. So numerator increase means size of the granule should be increased. That is, threshold value where genetic should be reduced. Similarly, upper can be reduced. And upper reduced means your threshold value should be increased. And even after changing, signal to noise ratio doesn't improve, what do you do? Increase the number of frames. So if you have 3 previous frames, you take 5. If you had 5, you increase 7. So this is a London metro. Look at this one. Frames per second, 5. 15 frames per second in tracking, and previous frames 5 and current 6. It's basically estimation. Previously it was rule-based classification, but both are unsupervised. See, completely tracked. It's an occlusion. Now, there are so many applications. Basically, these are machine learning tools. Basically, we have many applications for video conceptualization, bioinformatics, social link prediction. Social link prediction is very hot topic. You must work, some of you. Link prediction. But today you are friend, tomorrow you just may not be friend. What is the possibility? And tomorrow there could be a new friend. It's called link prediction problem. Obviously, it has got a very powerful application to e-commerce, air quality interpretation. Now, if you look at this, any research you do, you keep in mind that next 5 to 7 years, where are they going to use? Otherwise there is no use of this kind of research. Here comes the relevance to computer theory of perception, natural computing, big data, and data. computer theory perception means that you perform the computation based on performance, not by the measurement. For example, when you drive a car, you use the perception of distance, space, likelihood of your velocity. So you are not using any measurement and the driving. And the perception, because of the limited resolution capability of human brain, perception is imprecise. That means boundary is, and perception can accept granular. And natural computing is another thing, and if granulation characteristic of computer theory of perception, that is a very good research area. How to modeling computer theory of perception. The natural computing, as I mentioned, granular computing is a process that can abstract it from natural phenomena. So if granulation is inherent in our human and thinking process, it is a good candidate for computation. Last one is the big data handling, because I have shown computational gain. Many papers have come during COVID also on certain handling. Now when we are talking about big data handling, today deep learning is a must. Now what is deep learning? Learning in depth in different stages, in a layman's sense. Learning in different depth in different stages. And it's characterized by learning the data representation rather than task-specific activation. Machine learning, which is called shallow learning, they go by task-specific. That is, given this, given that, you learn it. But here I am giving more emphasis on learning the data representation. That's the basic difference. And now we have abundant data, therefore deep learning is a meaningful choice. But however, deep learning is time consuming and different to engineer because you have different layers. Here comes the significance of granulated deep learning. We get the new concept because we know that granulation can reduce the time, compromising some accuracy. Therefore, I will explain it will improve performance. What is granular? You know, deep learning network in CNN? You have idea, no? Those who do not have idea, I'm just giving you one slide. See, basically, this model. Input on its convolution layer, on its rectified linear unit, before that max pool, then fully connected network. This is a model. Now, in convolution neural network is very popular for image processing task, video. There are many models. LSTM model is good for time series data. You cannot use this one for others. Every architecture has some relevance for one. And in CNN, your object extraction means you label the objects with most probable classes and you track them class. And it is the convolution layer which is responsible to extract different kinds of features using different kinds of filters. Here is the challenge. And then DL-based object extraction, whether you net AlexNet or SNet, that means you use number of CNN repeatedly. But you cannot increase because that will only competition time also. So based on that, you make it one. So this is the basic concept. Now, given this CNN, which works for one, what is the granular concept? So now in the convolution layer, what we do? Suppose this is got a, we have a n by n matrix. I take 3 by 3 convolution. So 3 by 3, 3 by 3, 3 by 3. So what is the convolution? This is basically a dot product. I multiply it and then take average. So I replace as this corresponding to one value, this corresponding to one value, and convoluted output is dot product 1. So I reduce the 9 by 9 matrix to 3 by 3 matrix. That's how I downsize. Feature extracted, okay? Now I suppose I put, so you have compute 9 times, right? 1, 2, 3, 4, 5, 6, 7, and 9. Now suppose there is a granulation, I make it based on object background preparation. 3 granules. So I compute only 3 times because I compute once and I repeat. I compute once, I repeat. So my y will be same. Similarly, this one. So granulation scan only 3 times instead of 9 times. Significant speed up. This is the concept of granularity. That means I am throwing away the redundant. That means background. I am not interested in background basically. Physical meaning is I am not interested in background. I'm throwing it out by making granulation. Otherwise, if I start from the computing same convolutional layer for the background also, I'm wasting time. I'm not interested. In the process, I may lose little time, of course, but I'm gaining in terms of computation time. This is our concept we published in 2020 with one of our MTech students from Calcutta University. She did MTech dissertation with me. At that time, pandemic, we don't have that much time. Then I see that why don't you use it for two-stage detector? That means localization followed by tracking. This is very fast localization about, and there is a RCG network is a very popular thing. Region-based CNN, RCN. So first RCN, etc. So I take this, I put granulation. I make it even faster, that improves the performance during that. This is one of the last PhD student from IIT Kharagpur who has submitted our thesis. That's one. So I will go for granulated RCN model. That improves real-time detection speed and accuracy. What is the model? This is the RCN model we have. I am adding these LED blocks. I take the entire video as an input. But other RCN model, they take frame by frame. But I am considering temporal information, so I take the entire video. I compute the granules, spatial color granules. I compute the temporal granules because I am taking the video. Then I take the intersection, so I get spatial color granules. That means in the process I am reducing the junk things. But when I reduce the junk thing, again I am reducing here by taking intersection. So when I am doing, I may lose some information. So then in order to get it back, I put some anchors of different rectangular size. I put in a little money, and then those are my basically input. I'm sending for training and classification. That's the basic concept. When I'm retraining, because I'm retraining because of the addition, so I take the text AlexNet as a pre-train, then I make it transfer learning. I put it the additional, I retrain it. So what are my advantages? It takes videos directly from the input, which you cannot do in other area. Then it is spatio-temporal guidance that extracts more positive information. Then more importantly here, you are taking only the relevant portion of the object models as compared to the entire feature map. In other words, you are considering only empty feature map, which are relevant, not the entire feature map. So you gain in computation time and performance. Now I take a last example, this detection real-time traffic scenery. The real-time traffic scenery, for example, in Delhi, congested here, Calcutta, if you go this one, you are taking real one during foggy, rainy session, and the camera is widely apart. So the picture that you get very small. So conventional machine learning or computer vision you cannot use. Computer vision means you identify each and every face, then you track. But there I cannot do it. So it fails. But on the other hand, because if your detection is not good, the tracking will not be good. But on the other hand, I have got the asset piece, I have last 6 months or 1 year's data with me, stored. So why don't I take that sample as a model? Why don't you have deep learning? So there comes the significance of deep learning. So very, very important. Inaccurate detection affects tracking accuracy compared to use conventional vision system or machine learning. Therefore, significant deep learning, we now have abundant previous data. Then you will see the result. I am using on one of the Indian steel plants. It is first RCNA which is available in the market and use deep shot algorithm for the tracking. So CNN is for detection, not for tracking. Tracking is something. This is detecting 6 frames per second, and this is tracking is 29 frames, but I have reduced to 10 for visuality. There are 8 kinds of objects. What are those objects? As I mentioned, you look at this: car, bus, locomotive, truck, minibus, bike, scooter, bicycle, land, etc. So there are three kinds of, I put it. One, look at this. Three types, so all cars, bikes, and human beings. Three colors I put it. She said, detection speed 6 frames per second. Now I put spatio color diagram. I say RPN, the spatial color diagram. Look at this sound. Circles will come. Circles means which you could not detect in the previous method. See that those circles are coming. That those circles means in that frame you cannot detect. But using spatial color you could detect. Here the speed has dropped down to 5.6, but accuracy has increased. But if you set the spatio temporal, even it is now better than. So I have first RCN, then RPN, that is spatial color, then spatial temporal. There now the speed has increased to 5.6 frames as compared to spatial color, in spite of having intersection operator mode. Because the number of number of lower approaches that you receive, they are very effective. That increases the efficiency in spite of using those intersection additional operation. That is the beauty of it. So once you have this, you can have traffic anomaly detection. You can have the anomaly like collision and near miss. That is the next idea we publish. And you are using the G numbers concept. It's a very new concept. For the G number quantifies the abstraction of information in a scene or natural language. So given a scene, you can abstract the information. That is G number provides the linguistic description and describe the reliability of the detected anomaly class. Last slide, evolution of the discipline. That's very important. So I have 2 more times, 2 to 3 minutes. 2 to 3, last slide. See, this is for the beginner. Now look at the subject. Pattern recognition, as per the literature, if you go, this is 1960. We started working in India, I think it is late 60. TIFA, Indian Institute of Science and IS. These are the premier institutes all have been for cultivating new topics. And I joined in 1975, 1st March, as a CSI Senior Research Fellow at the Fellowship of 500 rupees, CSI Senior Fellow after completing MTech, and 1,000 rupees book grant. That's all, one. So, 60s, that's a roughly. After decade, image processing came, because image processing is expensive. In our defense also, they realized the importance of defense, see? So they tried it. I moved to Imperial College, I picked up something. 60. The AI and expert system came in 1980s. When you was in Berkeley, I did this, based on the realization of Alan Turing. Now, but that time subject could not survive because we don't have available data. In my institute, we organize AI course. But after 2 to 3 years, we had to stop because there is no job market on that. Then we had knowledge-based system, expert system. Why? Because pattern recognition has some limitation. And Americans love to give always new names. And we, India and China, we just run after this. There is a history. Indians love to give, there is a Lathijade statement. That we had electrical engineering, then we give the name computer science. Now your pattern recognition is old topic, because pattern has a limitation because it makes decision based on the measurement. But that's not how our human mind works. So that's why expert system became a buzzword in 80s. Everybody is publishing and getting part. Then we say, oh, no, that's not the working. It's a knowledge-based system. We have in UNDP in India 5 knowledge-based centers. TIFR, Indian Statistical Institute, IIT Madras, CDET, or IIT Kanpur. 5. 5-year project. What is the one? You generate new knowledge from the given rule base. So every time you are getting new terms, information retrieval, rule-based generation, knowledge-based, or every evolution you generate new terms with big hopes. Then in 1990, DM became 2000 because of www, internet came, and genome project, huge data. But data mining term was existing in statistical patterns when you go to library, not to Google search. But that time we could not use this. Then in big data, 2000 taken, V, 4 V's. Velocity, variety, volume, velocity, variety, and veracity. And each V could lead to a journal. Each V could lead to a different paradigm. But even after, without solving, now we are talking about data-driven science, deep learning, and deep learning. So you see, at each evaluation, they are all different to cater to the need of the society based on the data. We have big hopes, say new approaches for different tasks for the mother subject. So mother subject is pattern recognition, which has been evolved in every decade up to this. Maybe after 10 years, you will get another new name. If I'm alive, I will tell you, but if you can match it. So we have varying nature of data. For example, when we started working in 75 feature selection, how do you do? We have number of samples, speech data, few hundreds, and number of feature 2 or 3. We publish in itinerary transaction. Now you have few thousand features, number of samples is small. Because you are go to a hospital only when you are sick. So that time we assumed our statistical decision making pattern, number of features should be much less than the number of samples. So to extract a good feature, what do? We cluster in the sample space such that the distance between, we take those features so that the separation between clusters is maximum. That's how we publish paper in IEEE. But today, that paper will not be valid. Because now the number of features heterogeneous, few thousands. So now what do you do feature? You cluster in the feature space. So if you have few thousand features, you cluster it even to hundreds, then each cluster represents a granule. So you take the centroid of each cluster, so you reduce from few thousands to few hundreds. That's the paper highly cited in IEEE transition on PAMI, Artificial Machine Intelligence, new approaches one. So we have big hopes, new technology coined, but caution, don't jump into the deep learning right now. If you want to know deep learning, you have to know shallow learning. If you know shallow learning, you have to know neural network. It's a good career. If you want to know neural network, you need to know pattern recognition. If you do not do, then after a few years, you will have this of, oh, it's no good. What happened in 1980s for a neural network? When neural network revived in 1980s, I was the first person in India published women papers in IEEE transition neural networks. And I went to NASA, everybody is funding. But after a few years, so many journals came, but after 7 to 10 years, subject loses interest, government doesn't stop funding. Because everybody expected that dollar price expectation, race course, everything will be there winning money. And neural network transaction, IEEE, they have changed the name to neural network transaction and learning system. They are starting publishing subordinate because they don't get paper in neural network. Neural computing, they are publishing something else. Look at the history journals. Subject died. Today again, after deep learning, because they have again revived. So learning, machine learning means learning from previous experiment. So I have used the same concept today also. Once we have this massacre, I don't think that dissatisfaction should recur. So that's my request to the young, because otherwise everything is one. Now, it's a last note and a separate note. Excessive talk, any topic, but ignoring the growth of other disciplines may sometimes be no good, as it affects the progress of the overall science. That also you keep in mind. With this one, I conclude that this is the book we published during pandemic on Devarati, who is now in faculty in Hull, University of Hull, UK. During the COVID, we finished. acknowledge my students and young because I work my whole life with my students and younger colleagues in India. I didn't work with the big professor work. And I thank you very much. Thank you. Thank you. If you have visited China, Chengdu, you should visit. How much they are enjoying this life.
So we have time for one or two quick questions. Actually, we are already over the time limit. Anything, especially for young researchers, PhD scholars? Any questions? Yes, please. And on the screen, you will see a feedback form. So those who complete the feedback form, we will issue a certificate. E-certificate will be mailed in the coming days.
Hello sir, I'm Ayushi, I'm a PhD scholar, third year student. So I have a question. Like the concept of granules, we used point clouds and voxels in 2D representation and 3D representation of video frames, image frames. So can we compare granules with those? Because point clouds also hold some data like texture, color, and depth. So can it be related?
See, granule concept is not new. But the question, how you enjoy it? How do you use it? This concept. Preserving the information. Granule could be physical granule, granule could be information granule. I did not go for the information granule. You extract some relation, extract some equation. That is also important granule. Yes, you can use it provided those voxels preserve the information about the feature that you will be using following step for operation.
Okay.
Understand what? Say, in an image, its pixel can be considered as a granule. So it has an intensity. Its similar color could be also granule. But if I want to reduce the granularity, then I go each pixel is a granule. Understand? So if I want to go see object detection, I'm not interested in whether it's X or Y. It's some lady or man. So that's why I consider granule. So voxel, yes, voxel is a pixel. Further. But the question is whether the information you are preserving in that information, which will be used as a processing information. Because your object is to reducing the computation time. Understand? That's the basic concept.
Sir, I have another question. In that corner, CNN approach, we were using filters. So you said that we are iterating like 9 times. And by using the granular region, it takes about 3 times. So how we will find out that these are the regions that we have to take?
Color similarity. Segmentation. That's why I'm telling you that an image, I do not need the background information. That is the physical. But to be honest, I found a similar color image. So instead of 1 to 5 or some region wise, I have say 9 by 9, 81 pixel. Now if I can reduce it to 20, for example, instead of granule, that's my gain. Now so if I, in terms of filtering, since I will get 3 by 3, 3 by 3, I'm showing the gain. So every time I have to compute 9 times at least. But if I have 3 granules, I only 3 times. If I have 2 granules, reduce to 2 granules, I have only 2 times. I have 2 times. That means I am further reducing, but compromising some quality. Compromising some quality. That's why there is a balanced compromise. That's what you go to. Understand? That's what I showed in RCC granulation work. I have speed faster than 6 frames, but I have reduced to 5.6. But accuracy is improving. That much speed I have reduced, but at the same time gaining MVP, that is gain accuracy, precision accuracy. Accuracy and this is fast. Understand? That's what happened. See, nothing is free. Nothing is free. But all depends what do you want to prefer. What kind of application? Since it is a tracking, that's why I am comfortable. If it is my identification of human being, I may not be able to do identification, whether it is a Sheila or Rama. That I know.
Sir, can we use this concept in a synthesis, like video synthesis and reconstruction?
Yes. Only that you preserve the information so that when you synthesis, you use it. That's your trick. That is your things. So two concepts. Formation of granules, that granules evolve during evolution. Now we are thinking about making the granules adaptive. That means in the process, granule is evolving. You think that way. Granule is not fixed. Granule is evolving depending on the one. So granule evolve in the process.
The amount of the information it holds.
Information it holds because with time during the process, granule not necessarily be fixed. Whether it's information granule or it is a physical granule, it could be variable also. Right.
Thank you so much, sir.
Thank you. Any more questions? So, if you're happy, probably I'll ask Professor Paul to ask you some questions. What was that? Remote side, any questions?
Sir, how do you see the use of machine learning in the area of semiconductor or chips, basically?
No, this kind of answer cannot be written. The semiconductor, is there any problem where you
suppose that nowadays
just a minute, whether it's AI or machine, because machine learning is a part. AI is a clustering, is a AI. It is basically AI. But whether it's a learning, machine learning, that means you rely on the previous information. Understand? Don't confuse all those things. Yes, if you have got a problem where you need the previous information, then you call machine learning. Understand the thing? That you keep in mind. Don't try to put everything in here and there. AI, machine learning, under that deep learning, under that transfer learning, you think about this. Yeah, if you have some problems where you need the previous examples, previous instances, previous experiences to use, that is called machine learning. Then it will be applicable to use any kind of machine learning tools. That means you learn and then only use it.
When we design VLSI circuits, there can we use the AI, or how we can use, because nowadays industry is moving in
artificial intelligence, because when you are using a computer aided design, that's an AI. When you are computer aided design for the last 3 decades, this is an AI technique. That has been always used, but whether it's a machine learning used or not, AI has different components. Na?
Yes.
AI is just not a machine learning. Machine learning is just one component. Storing, processing, these are all in AI. Right?
And means if we want to use this your image processing, suppose that I have a problem where I want to detect disease in the poultry farm. And
you can use it.
Yeah. So there, if I want to detect the chickens or hens, so how I can use this means in terms of using the deep learning techniques there.
You see, you are not interested in the solving problem. You are using this one with deep learning. This is not good. If you have a chicken problem, etc., that is a standard AI techniques are available on this one.
Okay.
If you cannot solve with the existing one, because your machine learning algorithm is failing, on the other hand, you have subject and data available, then you think of deep learning. Deep learning is your learning from the data available. Understand? Previously you had not many data, you call it shallow learning. Now since you have enough data, you see whether that data can be exploited. Then the concept of deep learning.
Now suppose that I have an image which is from a low resolution camera.
Low resolution camera.
I want to use a simple camera. Suppose that 2 megapixel camera I am having with me. Now, if I want to detect disease, I need to go at a very small granule level.
Small, that means the final level.
Yes.
Final level, just do it. Then you don't go by the granular computing. The granular computing approximates. But if you want to start from the approximation and then go final, that will be economical. See, final, if you go by the final, that is expensive, right? Storing, you are paying already. Now, if you can solve this problem within your capacity or money, you do it. But suppose you do not have, you have the courser. So courser means it is already calculated. From there you see whether it can. Understand? Technology has limit because technology depends on the available data.
Is there any way that we can go from lower resolution to higher resolution?
Oh yes, yes, that has been already processed. Yeah, the task is called subpixel classification in image processing area. There is area called subpixel classification. That you have a pixel one, then from ambiguity you dissolve the pixel into just, you transform the pixel into final pixel. It's called subpixel classification. That is a well-established theory. Look at the image processing literature. That is a very common subpixel classification.
Thank
that
you
is
so
part
much.
of the pixel can be classified into many other pixels.
I think we are running short of time.
Yeah.
Probably we have to rush. So once again, on behalf of the university and all of you, I would like to especially thank Professor Sankar for we have a small gift for you.
What is gift again?
It's actually a series of books published by our
Okay, thank you. Okay.
So I guess if you have any more questions, you can always contact him through email or
This lecture,
Thank you so
please
much.
delete it. If you need, you ask me, I'll give the lecture. Because we have so many other, please delete it. So I don't get it. Okay, thank you very much, sir.